Electric car. Electric cars have been developed for years, since the 1890s. However, their success was limited because of their autonomy. Today, they meet a second revolution. Thanks to technological progress, our batteries now have a much bigger autonomy. We know for a fact that there will be cuts in petrol in a near future, so we need to change the energy we use today, and electricity is the main solution. Also, we need to reduce our greenhouse gases, facing the global warming. Those reasons support the car manufacturers to develop and design cleaner vehicles. How exactly does an electric car work? First, the batteries. So this is the inside of a battery. So at the right we have the anode, the negative electrode made of graphite, which wants to get rid of electrons. On the left we have the cathode made of lithium metal oxide, which wants electrons, and we're gonna have two conductive metal at the ends, aluminum and copper. At the center we have electrolyte solution with a separator which is permeable to lithium ion positive but not to simple electrons. So we have a charged battery and the lithium ions are stacked up on the anode. So to discharge the battery you connect the both ends. The electron wants to get to the positive side of the battery, to the cathode. So the electrons leave the anode and travel to the cathode through the engine. The lithium ion, which has lost an electron, becomes a lithium ion positive and breaks away from the anode. It from the anode and travels over to the cathode through the electrolyte and the separator. There it joins the electron to make a lithium ion again. Batteries are put low in the car. It's important because batteries are heavy, and by putting them down it allows the car to have a low center of gravity. We see that car manufacturers make new electric cars, but some adapt old vehicles that were petrol powered into electric vehicles. On those vehicles, the batteries are put in the same place than the fuel tank to have the same space available in the car. But with a battery, an electric car will never have the same autonomy than a fuel tank car. So manufacturers are trying to have a good compromise between the volume of a battery and its power. For example, today, with one fill, a thermic car can travel for an average 700 kilometers and fit 4 people with their baggages. An electric car can only travel 150 kilometers, but the batteries take some of the space. We can do better, to 450 kilometers, but then there's only space for 2 people. So, the engines. In all propulsions, not all of the energy aboard is used to power the wheels. For a petrol engine, only 10% of the energy is used to power the wheels, the rest being lost in combustion, heat, and friction. An electric engine functions on a much easier principle. It is made of a battery, a stator, and a rotor. A part is lost in heat, but 80% of the energy is used to power the wheels. Today, on a highway at 130 km per hour, electric cars can travel 150 kilometers. But if we drive slower to travel in town or at the countryside, we can run for 250 kilometers. All of that powered with a lithium-ion battery. But where does it come from? Its principal resources are situated in South America and in China. We found this precious metal in soil at a few meters deep. Geologists say those resources are enough to run all the cars on Earth electric, including batteries of phones and computers. But we will have to improve the recycling of the batteries of our cars that aren't really ecological. With electric cars, we don't need to go to the gas station because we can charge it at home. We only need to have a plug and an adapted cable. But how does a battery recharge? So when you charge the battery, an electron leaves the lithium ion and goes into the cable. Meanwhile, the lithium ion positive, since it has lost an electron, travels through the electrolyte to the anode. A new electron comes from the plug through the cable to the anode. It meets a lithium plus ion and it becomes a lithium ion atom. Normally, when charging with a normal cable and a normal plug, the atoms go slowly into the anode, taking an average time of 6 hours. Of course, if you want, you can go quicker, adding some flow. Then, the atoms rush from the cathode to the anode and can cause permanent damages. On a short term, it isn't notable, but with time, the battery can lose about 20% of its capacities. Are electric cars fully ecologic? Simply, does the electricity we use to charge our cars produce CO2? For this, we'll first talk about how electricity is produced in France. This is a pie chart of how electricity is produced in France. 3/4 of it is nuclear. It produces a little bit of CO2 and nuclear waste. The remaining is half renewable, including hydroelectricity, wind turbines, and solar panels. The other half is mainly non-renewable fossil energy that burn coal, petrol, and gas, which produce a lot of CO2. So this represents our daily electricity consumption. The fossil fuel centrals produce a lot of the energy during peaks of consumptions. If you charge your car during those periods, it will produce about 100 grams of CO2 every kilometer, about the same than a classic car. So we have to charge our cars during the night. If charged at night, a car will produce 10 to 20 grams of CO2 per kilometer. It's better. Countries like Poland, Germany, or China, where a large amount of electricity is produced by coal, electric cars won't be so ecologic. Hybrid cars. Hybrid cars have two engines, a thermal one and an electric one. When it's driven slowly, it drives electric, silently. At about 40 km per hour, it changes to thermal. But on a slope, the electric engine comes to help the thermal one. There are two families of hybrid vehicles. First, the parallel hybrid. When the car starts slowly to drive, the electric engine turns the wheels. When it needs to accelerate, the thermal engine starts to help the electric one to turn the wheels. Now, the series family. The thermal engine works permanently. It turns a generator that produces electricity for the electric motor that directly turns the wheels. Why put a thermal engine to get to work a second electric engine? For efficiency. Because if an engine runs always at the same speed without accelerating, it burns less fuel.